and he will speak in English. And you should be able to share your screen.
Le style d'une... C'est ça, ça fait lourd.
C'est un chemin, puisque c'est un chemin relatif.
On va commencer. Go ahead, Onur. We see your presentation now.
Can you hear me, Sylvie?
Yes.
Okay. So today we will be talking about event-based size measurement for reactive microservice-based systems. It is based on actually it was some of my insights about the topic is related with my PhD on reactive systems, and then I did a lot of research on software measurement, size measurement, and effort prediction. And then we also work a lot on the analysis and design of reactive microservices, how a methodology should be. We also work on AI-based size measurement. Together with the research work, we work on measurement in the field. So we work with large organizations mostly to create their measurement infrastructures. And then we also do software development together in the company that I am a shareholder. So I measure things, I research on software measurement, and then I put this expertise in the field, applying it on a software development company. So I will briefly talk about today. I think not everyone is about the software size measurement in software size measurement topic. So I will briefly talk about software size measurement, and then I will briefly talk about what is the impact of reactive microservices on today's software development community. And then I will be talking about a measurement approach we have developed recently, specifically targeting microservice-based systems. So software size measurement is actually based on the measurement idea and measurement theory. And then basically what we do is assigning numbers to properties of entities with respect to well-defined rules. So we usually use a reference quantity of some type like meter, and then compare how large or small a property of an object is related to this reference quantity. So we do this size measurement concept since Mesopotamian. So it's like 4000 BC. We used to have measures for measuring the length and volume and etc. So it's nothing new. And then we usually would like to apply a very simple measurement principle. As we assign numbers to define properties of entities, we need to keep actual relationships intact. This is one of the principles of measurement theory, which is very simple. So if Cecilia is longer than Matt, then the number representing the length of Cecilia should be higher than the number representing the length of Matt. This is a basic measurement principle. Most of the time, software organizations use measures like story points and use case points and things like that. This basically does not fit into this simple measurement principle. So there are a few size measurement approach that we use today, like cosmic, and then the concept is data movement. It's a reference quantity to measure software size, which is valid with respect to the measurement theory and the principle of assigning different properties to entities. We need to keep actual relationships intact. So this is actually the international system of units. We have certain base quantities that we think is the core of the measurement, which is related with the length, it's meter, and mass, it's kilogram, and time, second, etc. And then we don't have something like that in software area. Closest thing is data movement concept that we use when we measure things, functional size in software using cosmic size measurement method.
Onur,
go ahead, please go ahead.
Can you click on swap displays at the top of your screen?
Excuse me?
You should see a button, a swap displays under the big red bar, upper left corner. Swap displays. So swap, the third one. Swap. Yes.
So you are seeing the other way. Okay.
Thank you.
Okay. Thank you very much, Gene. Okay, thank you. Recently we have seen a tremendous difference in software architectures. Like Netflix, LinkedIn, many of the Facebook, all of them started using event-based architectures, which are microservice-based architectures. These are built using small autonomous services, and then they kind of work together. It's like shellfish working together. Instead of, we used to have monoliths, and then these monoliths have a single database, and all services are based on, are related with these databases. All of a sudden, we have seen microservices. They hold their data and functionality together, which are smaller units, and then it's like a shellfish. They work together to achieve a purpose. This created a big difference on software size measurement area as well. But first, let me briefly talk about why we need microservices. We used to have, during the last decade, we used to have small number of concurrent users. I mean, like thousands of, a couple of thousands. Now we have millions of concurrent users, like the programs like Facebook and LinkedIn and Netflix. We used to have dedicated service. Now we have cloud-based scalable service. So it's easy. It's a lot easier to scale up and down nowadays. We used to have slow networks, and now we have very fast networks. So it's easy to put our services on these servers, and then they can easily scale up, down on these servers. We used to deploy our systems on single machine. Now we are deploying them on variety of environments, and our services are working on mobile devices as well as computers and other systems. We used to kind of okay with seconds response time. I mean, we hit a enter and then we wait a couple of seconds. It was no problem. Nowadays, it is like we are expecting milliseconds response time. So if you make a search on Google, and then if you don't see a response in a second, you just close the web page. So it's kind of a new era. And then we used to have small well-defined data sets. Now we have large unstructured data sets that we have to deal with. So it's a single SQL database. Consistent data on a single server is not suitable for today's needs. So we need to be, we need to create services. They can be filled individually without disturbing the rest of the system. We should be able to have systems that can be easily scaled up and down. And then we should be able to have systems that are part of them can be easily upgraded. So that brought us to reactive systems. Sometimes, I mean, when people talk about microservices, it is not always reactive systems. Reactive systems are asynchronous, non-blocking consists of asynchronous, non-blocking message passing services. This is a key part. Only then we will be able to have large concurrent servers and utilize fast networks, deploy them on variety environments, and then have millisecond response time. Otherwise, just decomposing a large monolith into kind of microservices is usually not will not help a lot. This is mostly because our monoliths, and then if we decompose them into still sometimes we call them micro monoliths, are based on request-driven collaboration, and single database make it very easy to create an integrated solution. So we all know the request-driven collaboration. Like here's an example. This is a user interface service. We place an order, and then there is this order service, and then user interface service, when it places an order, waits a response from the order service, and then it might send a message to stock service, still waiting a response from the stock service before proceeding any further. So it was actually how we developed systems till now. But now with event-driven systems, we would like to have an event-driven collaboration. So in this case, user interface service will raise order requested event on an event log, and then those listening this event log like order service and stock service, when order requested have event rises, then order service immediately notice this and then do whatever it needs to do, and then eventually raise order confirmed event on the event log. And then stock service waits for this event. Actually, when this event raises, it does whatever it needs to do. So this way, nobody blocks each other, and then nobody waits anything from each other, and then they can, all services can be easily scale up and down. So, and then those services can also fail individually because nobody is waiting each other, and then user interface server can continue to receive new orders even order service is not responded for the first order. So this is the kind of architecture we are developing using microservice-based systems or reactive systems. So for this, we need to think in terms of events, because events are now are on the interface, not objects that used to be in building monoliths. So that's why we need to rethink about the size measurement approach as well. So in Cosmic, the base unit of this functional size measurement method was based on data and objects, and then we used to calculate objects coming into system, objects going out of system. But now we don't have objects coming in and objects coming out, but instead we have events on the interface. We put events on the event queue, we listen to those events, and then we do something when that event happens. So based on this, we need to rethink about the size measurement approach that we are using as well. So that's why we developed this size measurement method for microservices. It is basically using event as the base unit. Event is something that happens for a moment in the business domain, and it can easily be transformed into a software application as a form of an event that's happening in the event queue. So some examples like request arrives, check applicant, and application is approved. So request arrives a triggering event, and then application is approved is an event that can be easily placed on the event queue, and then based on this, a service can fire. So this is the base idea of micro event-based size measurement method. So we analyze the system, and then we identify the events in the system. We categorize the events as functional, architectural, and algorithmic events, where functional events can be user interaction or database interaction. User interaction can be input, output. Database interaction can be a database input, database output. And then we might have communication events that might be publish, subscribe, and sending a message. And then we might have algorithmic events, which might be a decision or calculation. So these are the things that we count as a size to create the software size using the problem analysis definition. So this is nicely this idea can be nicely used in an analysis which creates a event-based process chain notation. Let me show you a couple of examples. Like we usually analyze the problem using an event-based notation. We call it EPC, event-based process chain. So here, like we fill the form and form is filled and show order summary and order summary is shown. These are kind of user interactions. And then database interactions are like delete order, order is deleted, and read order, order is read. So these are kind of different types of events that we try to identify. Like,
excuse me, I have a question.
please go ahead.
Yes, Onur, thank you. Can you go back to the taxonomy of events?
This one? Yeah.
Yeah. So my first thought is to think of algorithmic as functional. Would process instead of functional be more appropriate?
We call it functional because usually this part is can nicely correlate with the functional size measurement approach we have we frequently use, like cosmic or IFBU. So that we kind of actually for us it's like an interaction event. But we call it functional because it nicely correlates with the functional size measurement approach. And algorithmic is, we call it process because I will show you some examples that when we drove the EEPC, if there is a decision or calculation on the EEPC, we are doing problem analysis, by the way, it shows as a activity these processes. So that's why we call it process. But this is kind of like, of course, these this is just a naming convention. But basically, these are the things that we identify as event. Of course, I just summarized the method that we achieved at the end of our research studies. We have several iterations of development of this method, actually. And then eventually we identify that this is a most valid types of events and that we need to count if we want to determine size based on the events. So,
thank you.
And then the communication is like subscribe to the applications queue and then publish the application result, and these are all result in application result is published, and then notification service is subscribed to the queue kind of events. So this process events, as we call them, is like there's a decision that we have to that our functionality separates into two branches, or we do actually some calculation like calculating the tags and export the list as XLX file and things like that. So let me show you how we use this approach, how we count based on this. And then this is a simple login example. When the user enters their email address and password to log into the system, the service checks the credentials from the database. If the credentials are correct, a login successful message is displayed to the user. And if incorrect, a login failed message is shown and the status is published to log. So this is a very easy login kind of use case. So when we draw the EEPC, it's like enter login credentials and then credentials are entered is an interaction event. And then read user info and user info is read from the database. It's again an interaction event. Check login credential, it is a process event because we have a decision here. And then confirmation message is shown, it's an interaction event because we display something on the screen. And then error message is shown, is again an interaction event. And then we publish the log, which is a communication event as we send something to the event log. So this is how we count the size based on in this small example. Let me skip this and then I think we don't have lots of time. So let me skip this and then give you some results related with what we found in case studies. So we actually performed 5 case studies on different organizations, and then in the first case study we use event point, the first draft method. In the second case study we use Micron version 1.0, and then in the rest we use Micron version 2.0. And then in each case we also use cosmic size measurement to see if which one perform better to predict the effort required in the projects they were performing. So we had different number of sample sizes, but these samples were different things actually. Some of them are like tasks, some of them are actual requirements documents. So the granularity of the measurement artifact is not the same in all cases. But still, we think they are quite comparable because we were able to measure cosmic and event point based on these measurement artifacts. And then the fifth case actually was a monolith, not a microservice-based system, but the first 4 cases were all microservice-based systems. So here you can see the results. We actually, what we tried to do was try to predict the effort that is utilized in these projects based on the sizes we have. So in most cases, we created multiple regression models to make sure that we count the differences on different types of events or different types of data moments in Cosmic. So here you can see the results. The Micron 2.0 performed quite good on all of the microservice-based applications. So this one, like the mean magnitude relative error was only 0.21. On the other one, it's 0.80. This one, the monolith, actually Cosmic performed better in predicting the effort required for this project. But this is understandable because it's a monolith, and then events are less significant in these types of systems. So you can see that we can nicely perform using Micron size measurement method. We are still doing lots of experiments on using this method, and then we hope that we will be able to release this method as a standard in the near future. So this is basically what I want to talk about today, and I will be very happy if you have questions so that I can go further deeper on topics that you would like to have.
So,
Afed has a question.
yes, I have a question. I don't know if Jean is still around. This will probably resonate for him. For your functional events taxonomy, so you mentioned decision and calculation. In the business rules world, those are both called business rules, so the calculation and the decision. And as I was listening to you, I was thinking of the decision modeling and decision modeling notation, DMN. I don't know if you're familiar with DMN.
Well, of course, during problem analysis, different notations can be used.
Right.
However, we find EEPC is a very nice match for microservice-based systems, because what we try to do in microservices is like as I described in this diagram, is trying to identify the events. I mean, between the services or parts of the system, we have events. And event-based problem analysis, like this one, enable us to identify the events between services. This is of course a very detailed one, but when you do this in a higher level, in a more abstract level, like in different parts of the system, first of all, it is very easy for experts to talk about events, like this happens and then we do this, and kind of analysis is very easy for them.
I do agree with you. What I'm thinking is the reason I mentioned DMN, decision modeling notation, is that one of the issues we face in any business rules is actually to evaluate the complexity of the decision. And so when I saw your presentation, I thought of DMN, and my intuition is not intuition, but something perhaps to look at is to see if one can associate a complexity, different complexities with different DMN constructs. Then you would also have a way of measuring the complexity of the functional events.
Of course, this might be very interesting, because now we always count all the decisions as one. But then some decisions might be quite complicated than others.
From my experience from many years ago, some of the decisions in finance or something, it's like 12, tens of thousands of rules.
Yeah.
So I don't know, how we can capture that, but anyway, so I would mention that. DMN and this.
Well, can be very interesting to look at. When you decompose into this level, like you see in this login, it's almost like use case scenario that is depicted in EEPC. If you can decompose into this level, usually it nicely correlates with the size measurement we get, nicely correlates with the effort spent for development of this microservice. This is as far as I can say. But then if you stay in the higher level, if decisions are very complex, and then if you want to create an effort prediction model from that abstract user scenario, then everything could be quite different. So in that case, how complex is the decision might be a good thing to look into.
Thank you very much.
Stay on that page. What elements are in your page would you count as an event? The gray area?
Yeah, the green ones, like credentials entered, it's an interaction event. User info read, it's an interaction event. Unsuccessful login, a process. Successful login, a process. And then after that, confirmation message is shown as an interaction event, and communication event.
that means it's 7 points.
That's correct.
Okay. And have you thought of any mechanism that your innovative technique could be an extension to Cosmic?
Yes, actually, it is. It can be considered an extension to Cosmic. Let me show you this one. So here, if you see this, we categorize the event into 3 levels or 3 categories. This functional part is almost exactly same as the Cosmic, but we don't really considered like abstract data type, object of interest, and things like that. We just, because we are just counting events here. But it's more or less is what concepts of cosmic functional size is all about. But here, publish, subscribe, message, and decision calculation is further analysis based on the like microservice architecture we have. So that's why we call them architectural, and then the other ones are algorithmic. But these are interesting because these are not necessarily identified during the design phase. These things can show themselves, can be easily calculated based on a well defined problem analysis stage. So like this one, it's only actually like a let me show. It's only like the level of analysis is like only a use case scenario, but we can identify different types of events at different actually abstraction levels here. Of course, we are thinking about like maybe we can create a size measurement approach that is valid on the requirements phase, design phase, and coding or programming phase. So which might correlate with this like functional, architectural, and algorithmic abstraction levels. And then event might be the concept that glue these parts together. But this is something we haven't explored yet.
Okay. Well, I may have a suggestion for you to explore also is based on events and types of system, you may be able to extract some patterns, measurement patterns that happens when a certain type of events occur.
That's very likely, yeah.
And when those patterns are known, it opens the door to early sizing.
Of course, these are all possibilities, Sylvie, I agree. Might be a good idea to explore like patterns, what patterns happen, and then how it correlates with size measurement. These are all things that can be explored.
Okay. I'll be looking forward for include your research output in the Cosmic method.
Yeah, we have been, one of my PhD students, Hussein, will finish his PhD soon, and then actually this is part of his thesis. And then based on his thesis, we can probably create a standard within Cosmic for microservices. That was something that we have been talking about during the Mensura conference.
I have a question about, thank you for the presentation. about the data here. You talk about Cosmic and all the methods before, and talk about data and objects. And here in the event-based system, you come back again to the some kind of data when you talk about output, database input, and so on, publish, subscribe. Yes, is event, but again, they are the objects and data again. So you come back to the maybe another kind of measurement, but my first question is about this is the data again. And second question, in which case, based on your experience, we can use the event-based or the other old methods to make the measurements? Thank you.
Data is essential, and then reading from database and writing to database is essential in any software system. So, but event is a more generic concept than writing to the database and then reading data. That's why I think the event concept is more relevant in all systems as well as the new systems, because like writing to a database is also event, but we don't just count those things. We also count like publish and subscribe kind of events as well. So this is the main difference, so that the event concept is more generic and can be applied to all types of architectures. But still, as I have shown you on the case study screen, Cosmic measurements with Cosmic correlates better on monoliths. So if we have a single database, a single server, it's a monolith system, then we can still use monolith, which is because in that case, like Cosmic is doing a more detailed analysis on object and data concept than what we did in event-based measurement. And then that nicely shows that Cosmic enables to measure size in a better way. I mean, I say better because it's a better correlation with effort. But the difference is not large, but still it's better. Cosmic is better. So I can say that if it is a monolith, you don't need to use an event-based measurement methodology, micro. Just use Cosmic.
You. And for those of you who do not know Cosmic is an acronym, Common Software Measurement International Consortium. Cosmic is the ISO standard 19761 for measuring the functional size of software, and it's been invented here at UQAM approximately 30 years ago.
So that's why I
in the mid-90s, and it's been evolving ever since. It's now version 5 that is published. All documents on Cosmic are available for free. The measurement guidelines and measurement manuals and stuff on the cosmic-sizing.org website. And I'm an executive member of the Cosmic group. I'm the treasurer. And my research has been done with Cosmic. My PhD was done on applying the Cosmic method on requirements as a method to identify defects in the requirements. And it turns out to be more efficient than a simple peer review. And if you ever want to learn what the Cosmic method is, how it works, we provide a course in summer, MGL 7240, where you learn the Cosmic method and for free, you can also do the certification exam. You need at least 75% to obtain the certification, but it's a good way. It's like putting an extra tool in your tool set. The software engineer, then we use the functional size to estimate effort of software development activities. Because there's a strong correlation between the software size and the effort that is required to complete the software development. Well, thank you, Onur. I hope that the weather is nice in Turkey.
It's perfect here still. How about Montreal? It was beautiful a couple of weeks ago.
21 degrees though.
Well, there's a bit of clouds today, but it's super hot. Normally in November, it's almost freezing, and today it's 23 degrees outside. So
Oh, then it is the same. Now you have a Mediterranean climate.
well, I hope to see you next year at the IWSM is it in Dubai?
I think so.
Dubai, yeah. Okay.
Yeah. Thank you very much for the opportunity. It's great to see you all.
Thank you.
Thank you very much.
Have a nice evening. Bye.
Bye. Thank you.